Welcome to another episode of Beyond the Basics, a reference guide for mathematics. This is episode 9, dividing positive and negative numbers. And we're going to start out by discussing what it means to divide. And we're going to talk about dividing by grouping and by patterns. I leave number line off of dividing. You can do it. In my opinion, it's not a good way to explain it. It can get really confusing. And then again, we're going to do the rules because the rules are really the easiest way to remember these things. So what is division? Division is making equal groups. Some people say that it's subtracting the same number over and over again, which you can think about that, and that really helps when you're working with remainders because you're really dividing things into groups, not necessarily taking things away. Equal grouping. So we're going to start out with our fire and ice as we have used many times in the past. This time we're looking at like 6 divided by 2 equals 3. You know that's a basic fact, which means you start out with 6 positives, and then you take those 6 positives and you divide them into groups of 2. And so you have 3 groups of 2 positives. So it's all positive, so your answer is positive. If you have negative 6 divided by 2, you're going to end up with negative 3, and here's why. You start out with 6 negatives. You divide them into 3 groups of 2. These are positive groups, and the positive groups don't change what's inside them, so it stays negatives. So you have 3 groups of 2 negatives, making your answer negative because all the groups are negative. What if you had positive 6 divided by negative 2? That also equals negative 3, but this time you start out with 6 fires and you divide them into negative groups. So the negative circles there makes what's inside them their opposite. So you end up with 3 negative groups, or the opposite of the first example there, which is the 3 groups of 2 positives, because those are all positives in this one, but you have negative groups, so it's the opposite of 3, which is negative 3. You'll notice in these two that only one portion of each one of these diagrams is negative. In the first one, the ice is negative. In the second one, the grouping is negative. So one part is negative, so the whole thing is negative. So you have 3 negative groups. In the last example, we have negative 6 divided by negative 2, and that equals a positive 3. Here's why. You take those 6 negatives and you divide them into 3 groups, 3 negative groups. And since you have a negative group and a negative inside, you have a double negative. You have the opposite of 2 groups of 2 negatives. So you have the opposite of this second example there. And when you have both parts negative, both the ice is negative and the circle negative, you have a double negative, meaning it's all positive because double negatives are not-nots like we discussed a couple of episodes ago, and not-nots are always positive. Now let's look at another way to describe it. We're going to be using patterns in dividing as it relates to multiplication. And we're going to be looking at like if-then statements. So if this is true, then something else is going to be true. So for example, if this is true, 3 times 2 is 6, and a positive times a positive is a positive, fact check, true. If that's true, then this is also true. So you can always understand division when you think about it as the reverse of multiplication, like this. The 6 goes to the front, the 3 goes to the end, and the 2 stays in the middle. So 6 divided by 2 is 3. Thus, a positive divided by a positive is going to be a positive. So if 3 times 2 is 6 is true, then 6 divided by 2 is 3 is also true. And if a positive times a positive is a positive, then a positive divided by a positive is also positive. Let's take a look at this with negatives. If this is true, 3 times negative 2 is negative 6, and a positive times a negative is a negative, and it is. We did that in a previous episode. If that's true, then this also has to be true. That negative 6 divided by negative 2 is 3. Thus, a negative divided by a negative is a positive, because it's just the reverse of 3 times negative 2 is negative 6. Has to be true. So if this is true, negative 3 times negative 2 is 6, and a negative times a negative is a positive, which it is true, then this also has to be true. That 6 divided by negative 2 is equal to negative 3, or positive divided by a negative is a negative. So we're using the multiplication rules to understand the division rules, because division is multiplication in reverse, just like subtraction is addition in reverse. These are our division rules. Let's look at these a little closer. These are all multiplication. These are all division. Those are the multiplication rules and those are the division rules. Something looks very familiar here. Look closely for patterns. Patterns are really what mathematics and algebra is all about. Understanding patterns and using those to predict the future. You notice that the first on both sides is all positive, and the middle one on both sides is a positive times a negative, or a positive divided by a negative, and their answers are both negative. And look at the last one in each group. I got it! The dividing rules are basically the same as the multiplying rules, but they're division instead of multiplying. You may also notice that when there's one negative, there is always a second negative, whether it's before or after the equal sign.
There's always two. These are not the negatives you're looking for.
Here are our notes. Pause as you need to get it copied down into your notebook. Two examples today of showing you how multiplication and division are related, and their integer rules are basically the same. Here are some practice examples. Thanks for watching, and I'll see you in our next video, which is going to give you some practical uses for positive and negative numbers.